Alright, you are watching the first section in Unit 5, Rational Functions. We are talking about 5.1, multiplying and dividing rational expressions. We have a couple things we got to talk about first. One is, what is the definition of a rational expression? It is basically an expression, okay, that has variables in a fraction. What that means is, I have a fraction here, we have a over b, and I could have numbers on the top and bottom with, say, a variable on the bottom. I could have a number on top with a variable over just a number on the bottom. I could have variables on top and bottom. I can have binomials, monomials, trinomials, whatever we want. Okay, basically it's just a fraction that has variables. That's what a rational expression is. And the reason it's an expression is because we don't have an equal sign. We're not solving anything yet. All we're going to do in this particular instance is multiply, divide. We're going to work on some simplifying as well. So first up here, these first five, let's simplify. So this is from when we first did fractions back in, I don't know, 5th grade or something like that when we started working with them. Maybe 6th grade, I don't know. But what we need to do is simplify this, make this smaller. So what can I divide them by? I can divide them both by 4, right? And I get 5 over 6. So that is our simplified fraction here. Basically what we're saying is, what do they both have in common? In this particular instance, if I look at these particular fractions, what do they both have in common? They both have an x. So because they both contain that, I can take away that same term, and what am I left with? I'm left with just 4 over 7. Now in this instance, we'll notice that we have what we call a monomial here. We have a binomial here, a binomial, and a binomial here. Okay? In order to cancel, I need the exact same thing in top and bottom. If I look, what's the exact same thing? X plus 3, x plus 3. They're the exact same thing. They have to be the same thing. Same. So therefore, what's left? 4 over, what? X minus 4, and that's your answer there for that one. Look at the fourth one here. What do they have the same? They both have a C. Cancel. What's left? A over B. This one here, okay, 4x plus 3, that is a binomial. 2x minus 9 is a binomial. What do I notice? Well, let's first see if we can factor anything out from the top. Can I divide 4 and 3 by anything that's the same? No, so the top stays the same as 4x plus 3. The bottom, can I factor anything out of here? 2 and 9, do they have anything in common? No, so that's 2x minus 9. Since nothing can cancel, okay, this is my answer. What some of you are going to do and say this, well, I have x's and they can both be divided by 2, and then I have a 3 and a 9 and they can be divided by 3. No, you have to divide the whole thing by the whole thing. I can't pick and choose numbers each separate term. These terms go together. 4x plus 3 go together. It's not separate, okay? You have to divide them by the same thing, top and bottom. Excluded values. What are excluded values? These are numbers that would make the denominator equal 0. That's very bad. Very bad. Why is that? Well, if that was a number and it made the denominator 0, remember I can't have my 0 in a denominator because it doesn't exist, right? We can't divide by 0. That's why it's very bad. That's why we call them excluded. We'll get to actually talking about excluded values on the next couple problems, but that's the definition of excluded. So now let's go on to the next kind of couple examples here. Okay, next example. Still want to simplify. Okay, so what we want to do is this. I want to simplify as best as we can. So then I want to find excluded values. The excluded values you have to do first, and then simplifying you have to do second. Alright, what do I mean by excluded values doing first? Well, this denominator, what I want to do is I want to make it equal 0. Okay? Same thing over here. I'll go over here as well first. So that denominator has to equal 0. I want to find the values that would make this 0. How do I do this? Well, we know this is quadratic, so I'm going to make an x. So negative 16 on top, 0 bottom, negative 4 and 4. So remember, I have to take these and flip them. So that's 4 and negative 4. So these here are my excluded values. That means that 4 and negative 4, if I plug it in, I get 0 in the denominator. And we said before that was very, very, very bad. So excluded values are 4 and negative 4. X cannot equal those two excluded values just like that. Now, I want to factor and simplify and do all this other stuff with this. So this was for excluded values. Now let's go on and factor. Well, x squared minus 16, again, we still have the x, right? We can even, maybe you left this from before or whatever, but negative 4 and 4. So that, remember, these here go into the parentheses. So x squared minus 16 is actually written as x minus 4, x plus 4. Okay? Oh, and that's under x plus 4. Well, what do they have in common, top and bottom? They both contain an x plus 4. So now my answer is x minus 4 in the denominator. What's up top? Well, there's nothing there. Well, nothing in this case means 1. We can't put a 0 because then that would make the whole thing 0. That would be false, right? So 1 over x minus 4. And this one here, p squared minus 2p minus 24 equals 0. I have to factor. I want to find the excluded values. Remember, that's the first thing I got to do. So negative 24, negative 2. What two numbers multiply to this and add to this? That's negative 6 and positive 4. So remember, to solve the equation here, I flip these numbers, 6 and negative 4. Those are my excluded values. That's the what x, or in this case, what p cannot be. Well, actually it should be a p, right? That's because it's p in the problem, not x. Okay, so that's what p cannot be, because then it would give me 0. Now let's figure out how to simplify this. So up top, okay, 2p squared minus 12p. What do they both have in common? Well, this and this both have a 2, so I can divide them by a 2. Don't they both have a p? One's got a 2 of them, one only has 1, so they both contain 1 of them. So if I take a 2p out of this binomial, what do I have left? So divide this by 2p. What's left? A p. And if I divide the negative 12p by 2p, what's left? A negative 6. So this is my numerator. My denominator is going to be, remember from the box here, we get p minus 6, p plus 4. Now what's the same? Binomial, binomial, gone. 2p over p plus 4. That is your answer for this problem right here. So the first thing that we're doing, we're finding the excluded values. The second thing is we're factoring top and bottom as much as we can. Okay? And then third thing is then we're simplifying and then we rewrite our answer. Okay? That's basically what we're doing. Now, multiplication of fractions. In this instance, rational fractions, right? We have fractions with variables. So how do I do this? Well, when I simplify fractions, even when you did, think about when you multiplied fractions back in, junior high. You took 1/2 times, say it was 8/9, okay? You could do 1 times 8, 2 times 9, and then you would reduce your final result. But remember, I could also simplify diagonally. So can I simplify 1 and 9? No. Could I simplify 8 and 2? Yes. This would be a 4, and this would be a 1. I divided them by 2, right? So then my answer would be 4 over 9, which is what I get if I reduce 8/18. So that's what I want to do here. The reason I want to simplify first is because my numbers at the end will be rather large if I don't, and we might get confused or discouraged when we're doing that. So I want to make sure that I simplify first. Now, how do I simplify correctly? I can simplify vertically or diagonally, never horizontally. Remember, horizontally is left or right. You cannot simplify left or right. Cannot. So let's get to the problem here. So let's look vertically here. Do they have anything in common? Yes. They both contain an x. So this x is gone. This x becomes a 1. Okay? Can they simplify any y's or numbers? No. Can I simplify anything this way? Yes. This has an x. This has an x. They both have one of them, so they're both gone. Okay? So now let's rewrite what we have left. We have 4 on top over 3xy times 9y to the 3 over 2. Now let's look diagonally. Can 4 and 2 be divided by anything? Yes, 2. So this becomes a 2. 4 divided by 2 is 2. 2 divided by 2 is 1. How about this diagonal? Yes. 3 divided by 3 is 1. 9 divided by 3 is 3. Do I have anything else that can be divided by? Yes, y. There's 1 y and 3 y's. How many do they have in common? Only one of them. So this is gone. This 3 now becomes a 2 because I took one away that was the same. So now what's left up top? 2, 3, y squared. 2 times 3 is 6 times y squared over what's on the bottom? 1 times x times 1 is x. That is your simplified answer for the first multiplication problem. Second one here. Well, none of it looks like it can cancel, okay, because if I go this way here, vertically, they're not exactly the same. Yes, I have an x here, but that doesn't mean anything. Can't cancel if they're not the same. I can't cancel here because they're not the same. Because they contain x's doesn't matter. So what I have to do is I have to try to factor what I can. Okay, so this 3x plus 9 can be written as 3 times x plus 3. I can take out a 3. They're both divisible by 3, so take it out. What's left? The x plus 3. If I were to redistribute, I would get what I started with. That's the whole point of factoring. X squared plus 7x plus 12. That gives me 12, 7. This gives me, 4 and 3, right? So 4 and 3. So this is x plus 4, boom. X plus 3, boom, right there. We got x squared minus 25. Again, I can do a box for that. So I got negative 25, 0, negative 5, and 5. So I got x minus 5, x plus 5. Oh, yeah. So now, vertically, can't do anything here, can't do anything here. Can I do anything diagonally? Yes. X plus 3. X plus 3's are gone, okay, because they're the same. X plus 5 and x plus 5 are gone. They're the same. What do I have left on top? I have this 3 still that I didn't touch. What do I have left on the bottom? X plus 4 and x minus 5. One of two ways. You could either multiply this together using a box, or you could leave it like this. That is okay as well. Either one of those answers are okay. If you did it the other way, then you would get 3 over x squared minus x minus 20. So both of these would be answers, and that's okay. Last example here for multiplication. You will notice that there's no fraction here, but technically there is. Oh, I just turned it into a fraction. Oh, I can't drop the mic because you won't be able to see it, or drop the pen, but I'm just telling you, I'm dropping it. Hope you heard that. Okay, so I put it over 1. Now, what do I got to do? I want to try to simplify. I can't do anything up here. I can't factor any n minus 3. I can't make it smaller, but I can make 4n squared plus 2n smaller. What can I take out? I can take out a 2 and an n. They both contain a 2n. What's left? 2n, because these two multiplied give me that, plus 1, because 2n times 1 is 2n. Okay, so let's rewrite this a little bit. I get n minus 3 over 2n times n plus 1 times, that's the denominator's a 1, right, from before here. Then 2n squared minus 5n minus 3, what I'm going to do with these, this polynomial, this trinomial here, is I'm going to put it into an x here and try to factor. See if I can. I might not be able to, but we're going to see if we can. Can I work on this? Right? Does that work? You tell me. The answer is no, because I have a negative 6 here. So that doesn't work. So let's see if I can find two numbers that do work. Let's see, negative 6 and positive 1. Does that work? Yes, it does. So negative 6 and positive 1. Now, I cannot go from here into n minus 6 and n plus 1. Can't do that. Why can't I do that? Well, because a is 2. Since a is 2, I have to divide these all by 2. What's negative 6 divided by 2? That's negative 3. What's 1 divided by 2? That's a fraction. I don't want to do that. So remember, the 2 kicks out and the 1 stays where it's at. So n minus 3, 2n plus 1. So that is down here. Okay? Now let's look at it from here. Does anything look the same vertically, vertically, diagonally, diagonally? Yes, there's two n minus 3s, but they're horizontal. I can't cross them out because they're right next to each other.
Now, if you look at the 2n plus 1s on the top and bottom there, I can cross those out. So that's what I did there. And then what do I have left on top? I have the n minus 3 and n minus 3. I have two of them. And then in your denominator, what is left? It's just the 2n, and therefore you have n minus 3 times n minus 3 over 2n, and that is your final answer for that problem.
Division. Hopefully you remember from division back in, again, junior high, that we have our first fraction. Say we're dividing a over b, dividing it by c over d. So what happens when we divide fractions is the first fraction stays, the operation turns to multiplication, and the second fraction, oh, this should be a d up here, sorry. And the second fraction flips. So remember, we changed it to multiplication, and I flip. Same thing here. I want to keep it the same. Times change to multiplication, and then flip 15 over 6x. Do not cancel out before you flip. Okay, you can't do that. So now let's cancel. X and 2 goes away, that's gone. 5 and the 15, this becomes a 3 and this becomes a 1. Okay, because I divided them by 5. This 3 becomes a 1 and this 6 becomes a 2 because I divided them by 3. Diagonally, you can do that. What's left up top? A 3. What's left on the bottom? A 2, an x, and another x. So that makes it a 2x squared on the bottom there. This one here. Again, I have a division, so I have to flip the second one. So it's m plus 5 over 2 minus m times m squared minus 4 over 3 times m plus 5. Well, right from the get-go, you can tell me that this m plus 5 and that m plus 5 are gone. We can do that because they're diagonal, right? Well, this m squared minus 4 is minus 4, 0, minus 2, minus 2. So it's really m minus 2m plus 2. So let's rewrite what I have left over. This becomes a 1, so it's 1 over 2 minus m times m minus 2 times m plus 2 over 3, because the m plus 5 gone, the 3 is left. Now some of you might be like, well, I'm okay, I can cancel the m minus 2 and the 2m minus m, or 2 minus m there. Can't do that. Do they look exactly the same? No, they don't. They don't look exactly the same. But they look similar. They look opposite. Like the 2 is positive and the m is negative. The 2 is negative, the m is positive. They look exactly the same, just opposite signs. Well, in terms of math, what is the sign that goes with opposite? Well, opposite means negative, right? So opposite means negative. And in this case, well, in every case, when we have an opposite, it always talks about a negative 1. So because these are opposites of one another, when I cancel them, I just get a negative 1 in its place. So m minus 2, 2 minus m, they're opposites. That's why it's a negative 1. The m plus 5 and the m plus 5s up here, they're the same. That's why it's positive 1. Okay? So what do I have left? On top, I have a negative 1 times an m plus 2 over 3. There is your answer for division. Okay, that's your second example there. All right, last one for division here. Okay, remember, since this is a fraction, this is technically over 1. Again, I don't want to drop my pencil or pen or whatever, so my mic dropped, but basically we think about the same thing. It's anything is always over 1 if we want to turn it into a fraction. So this is really y minus 4 over y plus 5 times 1 over y squared plus 5y minus 36. Okay, that's really what it is. All right. Now let's see if we can factor y squared plus 5y minus 36. So again, I have this minus 36. What do I have? I have positive 5 there. So this is a 9 and a negative 4. Because this is a 1, I can just put these straight into parentheses. So this is really y plus 9, y minus 4. 4. So what's the same? Y minus 4, gone with the y minus 4. 1s, right? Become 1s. What's left on top? A 1. What's left on the bottom? Y plus 5 times y plus 9. That is your answer for that one there. Okay? There are a couple try-it problems. I want you guys to work on them. You got simplifying, excluded values, multiplying, dividing. There should be 4 examples there. I want you guys to work on that. Pause video. Hit play when you get done. Find out if you're right. Okay, so come back to these problems here. How do I find excluded values, right? That's the first thing I want to do down here. So what I do is I take the denominator and I set it to 0. Okay, so equals 0. Then what I'm going to do is I'm going to factor out what I can. So if I look here, I divided by a 2, so I get x squared minus 25 left over, right? 50 divided by 2 is 25. 2x squared divided by 2 is x squared here. Then I notice this is a quadratic with the 2. You know, the degree, the power is 2, so it's quadratic. So I'm going to try to factor. When I do that, a times c is negative 25. B is 0. These two numbers add to 0 and multiply to negative 25. So that's what I get there. Now, since this is an equation and I'm solving it, it equals 0. That means that I can take these two numbers here and I can flip them. So when I flip them, I have a positive 5 and then a negative 5. And then I'm dividing by a. Well, in this case, a is 1, so that's why I get my excluded values right there. X cannot be negative 5 or positive 5. Now, how did I get kind of this all right here? Well, because I factored it, or I use the x here, these two numbers, negative 5 and 5, they go directly in to the binomial there with the x in front. So x minus 5, x plus 5, with that 2 out front. Well, now you notice that I have a binomial x plus 5 and another binomial x plus 5 stacked vertically. Remember, we can cancel vertically or diagonally when we're multiply or divide. I cannot cancel horizontally. So since these are vertical, I can cancel. They're gone. So I have x on top, 2x minus 5 left on the bottom. Right there, 2 times x minus 5. What I do not want to see you guys do is I do not want to see you guys say, oh, that's an x, I'm done, I cross them out. No, you can't do that, right? This is a monomial, this is a binomial. They need to be the exact same. Okay, exact same numbers, terms, variables, everything, nomials, they all need to line up. They need to be the same, everything. Can't cross them out. These here. Okay, what I did was I took the denominator here, I simplified, factored into x minus 10, x minus 3. I used the x to do that, right? So this was negative 10, this was positive 3. I plugged them into there. Then I rewrote it, x minus 7 over x minus 10, x minus 3. Then what I did up here is I took out an x. If you see that this contains an x and this contains an x, so I took out an x, so right here or right here. Then what was left? Well, x squared minus 9. Okay, x squared minus 9, that's what I get left. Then I notice this is also quadratic, so I can do the box, or the x, I'm sorry, that's negative 3 and 3. Again, put it into parentheses there. So now this is just rewritten here. Now if I notice x minus 3 and x minus 3, they are diagonal from each other. Boom, they can cancel. This x and this x are exactly the same, right? That's a monomial, that's a monomial. I can cancel them out. And what do I have left? Well, I have x minus 7 and x plus 3 left, binomial, so you can put them in your parentheses there. And then in the denominator, I have 2 times x minus 10. Again, you can write it many different ways. This is another way you could write it. If you wanted to, you could multiply these out using your box, but you don't have to. But if you wanted to, you get x squared minus 4x minus 21. And if you wanted to distribute that 2, you'd get 2x minus 20. So either way you wanted to write it, that's fine. Third one here. Remember, I can't do anything yet. I have to convert the division to multiplication, and then I have to flip my fraction. And when I flip it and get that. Now let's kind of divide some things here. So let's see what I get. Actually, this should be a 4 here. Sorry. I did it right. I just wrote down the wrong number. 20 divided by 5 is 4. And then this 4 and that 4 can cancel. They're diagonal, so I can cancel. I notice that I have a y up here and I have a y squared that was down here. Well, what I did is I have one y here and I have 2 of them here, so that means I can cancel one of them away. So I'm left with just 1. So what's up top? 3. Everything else is canceled. And what's on the bottom? Y. Everything else is canceled. So 3 over y. That was easy. Last one here. Remember, first thing I got to do is I got to turn this to multiplication, and then I got to flip. As I was flipping, so meanwhile, as I was flipping here, I took out a 6b from both of these terms. So took out a 6b, and that's where I got that from. So this should be in the top, right, my numerator, because I flipped it. And then what's left? Well, b, when I divide by 6b, I get b. And when I divide this by 6b, I get a -8. Okay, and that's where that comes from here. And then b squared minus 7b minus 8, I factored that using my x, right? -8, -7. I get -8 and 1, and then I put them into my parentheses here for my binomials. Then I crossed out diagonally. B minus 8, gone, diagonal. B plus 1, gone, vertical. What's left on top? 6b, bottom, b minus 9, you're done. All right, those are the try-out problems. There's 2 more problems right below. There's some, I guess, theoretical-based word problems. All right, I want you guys to answer them. Hit pause, answer them, and then hit play when you get done. All right, these problems are to basically identify how you would do this, right? This is how, not the process, not we're actually solving for an answer. It's just how would you do this. So, excluded values, remember that's the denominator makes 0. So I'm going to take the denominator, set it to 0. Well, it's a quadratic. So what do we know about quadratics? That means I can factor. Maybe. I don't know. We're going to see. So I get -4, -3 and -1. Now, because I equal 0, I'm going to take these values and flip them and then divide, and I get 3 and 1. So these are excluded values. Now, the question doesn't necessarily say how to find it, or it doesn't say find it, it says how. Okay, so explain how. So how would you explain? So you would say, take denominator, all right, set equal to 0, then solve. Well, how do I solve? Well, after I solve this, or when it says then solve, what do? First thing is I would factor, okay, because of a quadratic. That's why I'm factoring. If it was linear, meaning if your denominator was v plus 3, then I would just minus the 3, and I would get -3, and that would be our excluded value for this. But with quadratic, we know we have to factor. So factor because of quadratic, 2. So then you did your x, or do your x, and then take magic numbers. What are magic numbers? Well, these are these here. These are the magic ones that multiply and add and so on. Take magic numbers and flip and divide. Divide by what? Some of us we're forgetting. Divide by a. In this case, a is 1 with the v squared is 1, so I'm dividing, and that's why I put a 1 right there. Okay, so divide by a. So there you go. Those are your steps. That is how you find excluded values in that expression. What is the difference from multiplying versus dividing? For multiplying, we can just cancel from the beginning. Meaning that if something was a fraction times a fraction, I could look here and cancel. I can look here and cancel vertically or vertically and just start canceling. For dividing, remember I have to change the divide sign to multiply and take the reciprocal. Some of you are like, what's reciprocal? Remember, reciprocal is just flipping the second fraction. And then what happens? Well, then it turns into a multiplying problem, and then I can do all the multiplying stuff that I've done before. All right, that finishes up with your notes from 5-1. Work on the practice. All right, take notes, do work, be successful.